Anvai, hello.
Hello?
Yeah,
Hello,
ma'am,
ma'am.
there. You can proceed.
Yes, sir. Yes, sir. I'm here. Yes, sir.
Yeah.
Okay, so good afternoon, everyone. Today we have with us Dr. Madhuri, ma'am. She is a machine learning expert. She is also an experienced professor with a strong background in computer science and engineering. She has an expertise in machine learning, computer architecture, IoT, data communication, and computer networks. So today our topic of session is from algorithms to applications, key skills for advancing in machine learning careers. So, ma'am, I heartily welcome you on behalf of IFT, and let's start with us with our session.
Thank you very much. First of all, I would like to extend my gratitude to the IST team and CSC department for providing me with this wonderful opportunity to connect with you all today. So it's a great honor to share my experiences with such enthusiastic group of students. I thank College of Engineering Karat for organizing this webinar. I'm excited to be part of this event, and I hope by the end of this session, you'll take away some valuable insights that can help you in your academic and professional journeys. So without further ado, shall we start with our presentation?
Yes, sure, ma'am.
Yes, yes, thank you. I'll share my screen. Is the screen visible?
Yes, ma'am.
Thank you. Yes. So we'll be discussing some of the fundamentals of machine learning and real world applications of ML. And finally, we'll discuss about the career paths in ML. So have you ever wondered how your phone can automatically sort your photos into albums, or how streaming services can seem to know exactly what movie you want to watch next, or how a computer can recognize digits with incredible accuracy? Or maybe you've also noticed how online shopping platforms recommend products you didn't even know you needed. This is machine learning, where systems learn from experience and data just like we do. So, as you watch this video of a father trying to teach his son how to ride a bicycle, notice how the child doesn't follow a set of rules. He tries, falls, learns from his mistakes, and gradually improves. This is exactly how machine learning works. So, machine learning doesn't need explicit instructions for every task. Instead, it tries, fails, learns from those failures, and then improves over time, just like a child who's trying to learn riding a bicycle. So, on the whole, machine learning involves feeding data into a model, allowing it to learn patterns and make predictions, as shown in this simple overview. So, before we dive into machine learning, there's an important question that often comes up, especially in interviews. They say, do you really understand ML, or are you just making things up? So, to answer this, let's first explore the relationship between three key concepts: artificial intelligence, machine learning, and deep learning. As shown in this Venn diagram, AI is a broadest concept. It refers to machines or systems designed to perform tasks that usually requires human intelligence. Whereas machine learning is a subset of AI where systems learn from data and improve over time. On the other hand, deep learning is a specialized subset within ML that focuses on using complex neural networks. So now let's break this concept down individually, starting with AI using some example. On one side, we have non-intelligent machines like a basic watch or a vehicle. These machines cannot think, make decisions, or adapt to new situations. They simply follow instructions and perform repetitive tasks without any learning or reasoning involved. On the other hand, we have intelligent machines like autonomous vehicles, such as a Tesla car that uses Google Assistance for its functions. And these machines have the ability to process data, make real decisions, and adapt to changing conditions on road, much like a human driver would. So in short, AI is all about creating machines that can do more than just follow orders. So now let's dive into machine learning. Imagine you have a system and you have given a task to detect whether the image shows Iron Man or Captain America. So in our tradition or conventional approach, the system would need to be manually programmed with rules for each character. But with machine learning approach, it's totally different. Instead of giving rules, we feed the system with numerous images of Iron Man and Captain America along with their labels. The system learns to identify patterns such as color, shape, and other features, and uses those patterns to make predictions. When given a new image, the system can predict whether it's an Iron Man or Captain America based on what it has learned from the data. So this is the core idea of machine learning, using data to teach a system how to recognize patterns and make accurate predictions. So exploring deep learning, at the heart of deep learning is the AI, artificial neural network, a model inspired by a human brain. Here you can see each neuron in the network receives information, processes it, and then passes the output to another neuron, just like how human brain works. So, but as of now, we can just understand that these networks are powerful tools for recognizing complex patterns in data. We can dive this deeper into in future sessions. But keeping our core concept and our core agenda, we'll first look into the fundamentals of ML, where ML is a technique used to implement AI that can learn from data by themselves without being explicitly programmed. For an example, let's say a task is to detect whether an image shows a dog or a cat. The system doesn't have any rules. Instead, it learns by analyzing patterns in the data. We feed it with many images of dogs and cats over time. It learns to identify these patterns and make accurate predictions. So let's look into the three types of machine learning: supervised, unsupervised, and reinforced learning. And each type is used for different tasks, and we'll touch upon them in a more detail one by one. So in supervised learning, the algorithm learns from labeled data. Let us consider an example where we have labeled images of apples and mangoes. The system is trained with these labeled images, and the model learns to recognize the differences between them. Once trained, the model can predict the label of an unknown image. For instance, when given an image of an apple, the model will correctly identify it as apple based on the patterns it has learned from the label data. So let's discuss on the types of machine learning. And in supervised learning, there are two main types: classification and regression. Whereas classification is about prediction, and it could be a class or a discrete value, whereas regression is about predicting a quantity or a continuous values, where we try to predict a person's salary, age, or a price of certain house based on certain features. So let's look at the examples for both classification and regression in supervised learning. In this type of classification, the goal is to predict a class label. For example, we can train the model to recognize whether an image is of a dog or a cat based on patterns in the image data. Here in regression, the model predicts a continuous value. For example, by training the model on temperature data, we can predict the amount of rainfall in centimeters based on certain factors like temperature or humidity. So here are some of the common algorithms used for classification and regression in supervised learning. Let's move ahead and discuss unsupervised learning. So unlike supervised learning, where we use labeled data, in unsupervised learning, the algorithm learns from unlabeled data and tries to find hidden patterns or groupings. Let's see for an example. Given a mix of apples and mangoes, the algorithm groups them into two categories. Group 1 is for apples and group 2 for mangoes, based on their similarities, even though we didn't provide any labels. There are two main types of supervised unsupervised learning, that is clustering and association. And whereas clustering involves similar data points together, and in association, it's used to find important relationships between data points. For an example, in market basket analysis, where it identifies items that are often brought together. So in this, we can see in clustering, the goal is to group similar data points together based on their features. For an example, the system can categorize different types of communication methods, such as calls or Wi-Fi, into separate groups. In this visual, we see data points being clustered into two distinct groups. This is an example of how clustering algorithm organize data points on similarities without any predefined labels. Here is association, which is about finding relationship between different items. For an example, based on past customer purchases. If a customer buys bread, it is highly likely that they will also buy milk. This is very useful for market basket analysis and recommendation systems. So here are some of the algorithms used in unsupervised learning: K-means clustering, hierarchical clustering, PCA, a priori, and ECLAT. So the last type of ML is reinforcement learning, which focuses on how intelligent agents like actions in an environment to maximize rewards. So let's take an example. Imagine a chess playing AI, okay, and the agent here is AI, makes a move on the chessboard, and the environment is the chessboard, aiming to win the game by maximizing his rewards, that is victories. In reinforcement learning, the process involves environment where the world the agent interacts with, just like a chessboard, and agent is the decision maker, such as an AI that plays the game, and action is the move that every agent makes, just like moving in a chess piece. And reward is nothing but the feedback that agent gives based on its action, like winning or losing the game. So here is a complete mind map that outlines the types of ML. We see here supervised, unsupervised, and reinforced learning. It also highlights the algorithms and some real world applications. You can see under regression, classification, clustering, association, and we can see in reinforcement learning also. So here are some of the popular tools such as used in machine learning, such as TensorFlow, Keras, then we have Scikit-learn and Amazon SageMaker. These tools are specialized software or libraries used for specific tasks in machine learning, like data manipulation, or we can say in model evaluation. So here are some of the frameworks, on the other hand, we can see which are used to build and train and deploy machine learning models. These are some of the popular frameworks. We can see TensorFlow that will be used very hugely. The question comes, where to collect data for machine learning? So where do you think we can collect the data need to train our machine learning models? So here is an example to build a machine learning model that can distinguish between dogs and cats. We need to collect data. Images labeled as dog or a cat, this data will train the model to recognize the predict new images accordingly. So as we discussed earlier, here are some great resources to collect data sets for machine learning projects like Kaggle, a very popular platform with numerous data sets for ML problems. UCI Machine Learning Repository, a collection of data sets for academics research. Then we have here Google Dataset Search, a tool for finding data sets for multiple sources online. So in machine learning, we typically divide the data sets into two parts, 70% for training the model and 30% for testing its performance. This ensures that the model learns from one set of data and is evaluated on a separate set to check its ability. So here is a workflow of the ML project. Typically, it involves 6 steps: data collection, where we gather the data used for training, then data preprocessing, clean and transform the data for the model. Then third step is for data analysis, where we analyze the data to understand the patterns and relationships. Fourth comes the train and test split, which splits the data into training and testing, sometimes 70% to 30%, in sometimes 80 to 20%. Then model building, create a train, the machine learning model. Evaluation, evaluate the model performance on test set. So just like a student practices with exercises before the exam, training data helps the model learn, and testing data is used to evaluate how well the model performs. So now let's understand how to choose the right machine learning model. Selecting the right model depends on the problem you're solving, the data you're working with, and the performance requirements. So here you can see model selection is a process of choosing the best model for a given problem. It depends on factors like data set, task, and model type. For example, you can choose logistic regression, k-means clustering, or a neural network based on the problem you're solving. So models can be selected based on the types of data available, like it could be an images or videos. We can use CNN for that. Text or speech data, where RNN can be selected. Then for numerical data, we can have support vector machines, logistic regressions, decision trees, etc. Then based on the task we need to carry out, we have classification, regression, and clustering task. So mathematics plays a crucial role in machine learning, and mathematics is very essential in machine learning for processing data, building models, and optimizing algorithms for better performance. Here are the key areas that include, like linear algebra we require for handling data in vector and matrix platform, and statistics for analyzing data, probability to make predictions, calculus for optimizing algorithms. So let us discuss some interesting use cases in machine learning, starting with the project on predicting whether objects detected by a submarine sonar are rocks or mines. So here is the workflow for this project, which involves pre-processing sonar data and splitting it into training and test set, training a logistic regression model, using the trained model to predict whether new data represents a rock or a mine. So similarly, we use cases such as fake news prediction, car price prediction, hard disease prediction. Then we see spam mail prediction, credit card fraud detection. These all problem statements use logistic regression, and they can be greatly explored also. One such, we can see another use case in machine learning is to predict diabetes, showcasing how ML can be applied in healthcare domain. So the workflow for this project involves pre-processing diabetes data and splitting it into training and testing sets, training a support vector machine classifier upon the, and again, using the trained SVM model to predict whether a person is diabetic or non-diabetic using new data. So the workflow for the diabetic prediction involves pre-processing, splitting into training. And this is where whenever we get a new data, we can indicate whether it's a diabetic case or a non-diabetic case. In this project, we use k-means clustering to group customers based on their behavior and characteristics. So the workflow for this customer segmentation involves pre-processing customer data and analyzing it, visualizing the clusters, then applying k-means clustering and determining the optimum number of clusters using the WCSS method. Another fantastic or a very fascinating use case in machine learning is building a movie recommendation system to suggest movies based on user preferences. Similarly, just like YouTube recommends videos, musics, or TV shows based on your interest, a recommendation system suggests content based on user preferences. The workflow for the movie recommendation system involves preprocessing data, extracting features, and using cosine similarity to match user input with similar movies. These were some of the exciting use cases and projects that can be done using machine learning approach. Tech layoffs in 2025 are alarming. So did you know that major companies like Intel, Microsoft, and TCS and others have already laid off thousands of employees? Over 50,000 people have already lost their jobs, and the numbers are still rising. So the headlines in the top publications like Economic Times, Times of India, and India Today are deeply troubling as the job market faces this massive cuts. So, but while these challenges unfold, machine learning is opening new doors to new career opportunities. So here are top 10 ML jobs in India as per the latest 2025 analysis. So machine learning engineer, data scientist, research scientist, AI engineer, computer vision engineer, deep learning engineer, NLP engineer, data engineer, software engineer, business intelligence developer. So these are paving the way for exciting career paths in India. Moving ahead, to excel in machine learning careers, it is essential to be familiar with key tools like AWS, Google Cloud, then Microsoft Azure, big data tools like Hadoop, Spark, and some of the data processing tools like Hadoop and Apache. They are great for machine learning careers. So to build a strong ML profile or a portfolio which focuses on practical projects showcasing end-to-end solutions, maintaining a professional GitHub with clean code, and engaging in Kaggle competitions to demonstrate your skills and learn from top solutions. So this will help us to build a very strong ML portfolio. Here are some of the key essential certifications for ML careers. Certifications like Coursera's deep learning specialization, and where we can, these are the industry recognized ML courses from top universities. You have 5 courses for deep learning specialization. Then there are hands-on projects offered by Google, where there is TensorFlow developer. Then these are the industry recognized credentials. You have the hands-on projects to boost your ML career. Then there are some more certifications for ML careers. Google's machine learning crash course and Simplilearn's AI/ML courses offer essential certifications with hands-on training for those aspiring ML professionals, as I have started my journey with these careers. So we have taken this journey through the essential aspects of machine learning, and we are end of this presentation. And throughout this presentation, we have taken some key takeaways where we have understood some machine learning basics. We've discussed some foundational concepts like supervised, unsupervised, and reinforcement learning with some examples to understand them much better. We have explored some real-world use cases, or you can say machine learning projects, where such as customer segmentation, diabetics prediction, heart disease prediction, movie recommendation system, and how they demonstrate the machine learning, how it is shaping the industries with respect to healthcare and with respect to industry domain. Then we looked into some of the career paths in machine learning and the demand for roles like ML engineer, data scientist, and AI engineer is growing rapidly. Then lastly, we looked into some essential tools and certifications And these like key tools such as AWS, Google Cloud, and certifications such as Coursera and TensorFlow are essential to advance in the machine learning field. So, with this, I thank you all for your time and attention. I hope this session has provided you with all the valuable insights into this exciting world of machine learning. Wishing all the best as you continue for learning in this field. So, with this,
Hello, ma'am.
yes, Revan, over to you.
Yes, ma'am. Ma'am, I have one question.
Yes.
As of beginners, ma'am,
Mhm.
can you tell any roadmap, ma'am? One roadmap. If you have any considered any roadmap that will help to boost our machine learning skills?
That's a very fantastic question, Rihan, you have raised. This is what the budding engineers are really looking for. First thing, uh, I personally recommend is passion to learn machine learning. That is the basic requirement. I also started a journey just like you. I just wanted to keep myself updated and go with the market. Passion to learn, that is the only prerequisite to start your journey, just to trigger ML journey. So I really cultivated that interest. I want to learn. So do not think that it has to be learned. It's part of a curriculum. If you study, then that cannot happen. I had that passion to get myself updated to ML and AI. That is the industry requirement. So I had passion within me. Then I started my journey with some free courses that are available. I showed you some of the courses which are paid and some of the courses which are also free of cost. I had to look for the resources in that are available in internet. Loads of resources are available in internet, wherein you can just grab those courses, start learning from scratch. So I had to go myself with some courses. Then, firstly, I had passion to learn. Though I had this course was nowhere available past 10 years, previous 10 years. It is now, this course is now actually is a great demand in industry. Earlier, there was no machine learning or there was no AI. Then I had that passion. Then I took up some very good free courses that were available, short crash courses. But I personally tell you, no 15 days or 30 days crash course can complete your learning in ML. You minimum, I at least rigorously went minimum 3 months to understand what is ML. I took all my time to understand this, and now I'm an enthusiastic learner and still learning ML. It's a very broader aspect wherein you can, if you know, understand the foundations of DL and the fundamentals of machine learning, this is where you implement AI. So this is my recommendation. This is what I say to you.
Yes, ma'am. Thank you, ma'am.
That's very
Guys,
great. I hope this session was insightful, and I hope I could cover up in a very short time the journey from what is machine learning. We started with what is machine learning, and then we dived into what is the career opportunities and to boost your career in ML.
हो म्हणजे ते क्वेश्चन करतायत.
Over to you.
Yes, guys. Anyone have questions? You can ask. तुम्ही काय विचारणार आहे? बोला की सर काय ते. एखादा क्वेश्चन करा.
Hello, ma'am.
Yes.
For approaching AI or ML jobs, what type of projects are expected, like chatbots or any other recommendation systems?
Yes, hugely. If you look into healthcare, it depends on which industry you're looking forward to work with. If you're looking into an industry problem statement, it is all about automating. We need to automate. We have a very good connect with our industries, and irrespective of whichever domain you are, as of now in our college, in our institute, we ML is introduced for mechanical students, ML is introduced for aeronautical students, ML is introduced for civil, ML is introduced into such non computer science domains. As you can see, ML is no more restricted only to computer science background students. It is all over. We want in mechanical, the automation has to happen, wherein you can, if they wants to get into an industry wherein they want the huge data that has been collected, that has to be analyzed, and the prediction has to be made. Now if you look into aeronautical, then here in the field of aviation, you need a lot of predictions, where the data has to analyze greatly and into deeply. So it depends on which industry you are looking into, in where are you actually looking for, and based on that the problem statement could be in terms of industry, it could be in finance sector, it could be in it could be in banks sector, wherein they give you a problem statement and they want you to, if it is you can say customer segmentation, could be a very good problem statement. And whereas in financial sector, there is a huge problem statements that are available in banking sector. When you look into industry, it is automation is everywhere, automation is everywhere. So whichever domain you're looking into, ML is actually the main foundation for all such kinds of automation. So it irrespective of finance, irrespective of healthcare, irrespective of industries. So based on the type of domain, you'll have to choose your problem statement. I hope I've answered you.
Yes, ma'am. Thank you so much.
Welcome.
If anyone has any other question, please ask.
All I wish you all is wish you all the best for your career ahead. Please keep updated, learn new, something new, have the passion to learn something new. That itself drives you to the new world. So do not get choose projects or a kind of a problem statement that is already existing and available in the YouTube with codes, ready-made codes, or any kind of which is already having the flow. Please start with a new direction and connect with the industry people, and get the problem statements wherein you can start right away. So that is my strong recommendation to you students to build a very strong ML career.
Thank you so much, ma'am. It was indeed an insightful session,
Yes.
and it was wonderful hearing you.
Thank you so much. And I'm really very grateful, and to the College of Engineering Karad and IST team who has coordinated and given me this wonderful opportunity. I'm really excited for further collaboration and association with this team. And special thanks to Rihan and for giving me this opportunity. I'm really grateful to the head of the department who has trusted me and given me this opportunity. I wish you all the best for a great and a bright future ahead. Okay, so yes, Rihan.
Yes, ma'am. Actually, we are planning to organize offline session, but
Okay,
this time inconvenience happened that we are not available.
yes,
But
so definitely.
in upcoming days, we will again invite you, madam.
Yes, yes, sure, sure. It's my pleasure, and I'll be definitely excited to see you all there. We'll come up with some hands-on approach. That is what I look for offline. We'll come with a team there to assist the students to come up with machine learning. We'll bring some projects wherein students can work on hands-on. That we will plan, and definitely we will be seeing you soon there with some exciting material with lots of hands-on. That will be happening in future sessions, and definitely see you all. Till then, wish you all good luck.
Thank you, madam.
Welcome, welcome.
Thank you, ma'am.
Thank you. Okay, can we leave?
Yes, ma'am.
Sure.
Yes, thank you. Bye bye.
ॲक्च्युली आमच्या क्लास टीचर होत्या बीटेक क्लास आणि म्हणजे खूप असं एज्युकेशन चांगलं होतं एज्युकेशन वगैरे आणि नोट्स वगैरे प्रोव्हाइड करून आणि
पोरीला अजून काय करतात